All right, let's go ahead and get started. A couple housekeeping things real quick. This session is being recorded, and it will be posted to Channel 9 after the event. So if you could, silence your cell phones or other devices that might make noise. And also, even though it's being recorded, you are, of course, feel free to take notes or take pictures of what's on the screen. But you will not only get the recording after the event, but you'll also get all the slides as well. For those of you who don't know me, my name is Scott Schnall. I'm a senior program manager in the customer experience organization of Office 365. My particular team, the market development team, is responsible for removing any barriers to adoption of Office 365 in the areas of risk assurance or compliance or regulation, auditing, security, privacy, trust, and so forth. So if you do have any questions about those areas, feel free to catch me after the event. Or after the session, rather, at the hub, or feel free to send me an email, schnall@microsoft.com. All right, so today we're here to talk about the Exchange Server Preferred Architecture. Let's just do a quick check of who's in the room. How many of you are running Exchange 2007? Anybody still running 2007? All right, any 2010 in the room? All right, fair amount. 2013 in the room. All right, how many of you have had a chance to check out the 2016 preview? One person. Okay, two people. All right. Okay, well, we're going to talk a lot about 2016 and somewhat about 2013 as well, as we talk about things like Exchange fundamentals and the architecture changes that we've made in the product. We'll talk about the client connectivity changes that are occurring as a result of that. We'll talk a little bit about some namespace and load balancing planning for Exchange, and then we'll get into what our preferred architecture is for on-premises deployments of Exchange. All right, so let's talk about the Exchange fundamentals first. Again, I'm going to focus primarily on 2016, but where there are differences, I'll point them out, including with the primary architecture. For those of you who are wondering, Exchange 2016 is still on track to be released by the end of this year. It's actually coming very soon. Its release is fairly imminent. So those of you who are interested in going, say, for example, from 2010 to 2016, you'll be able to do that very soon. One of the more significant changes that we've made is we have once again reduced the number of internal server roles that you can deploy with Exchange. In fact, we've reduced it down to one, just the mailbox role. So all of the other services that were in the only other server role we had in 2013, the client access server role, are now client access services that exist just on the mailbox role. Part of that is related to deployment reasons. Other is related to architectural reasons, as we'll talk about in a bit. But this is pretty much the architecture, the enterprise on-premises deployment scenario that you'd see with 2016, where inside you've got a bunch of 2016 mailbox servers. They have both the front-end client services stack, the full core protocols, and of course the back-end database availability group where the mailboxes and storage reside as well. Outside, in the internet or in a perimeter network, we've got the Edge Transport Server, which will ship at RTM in 2016. That's different from 2013, where we waited till Service Pack 1 to ship it. In 2016, we're shipping the Edge Transport Server at RTM. Out of curiosity, how many of you are using Edge Transport today? Okay. Now, of those of you who are using it, how many of you are using it for secure email in a hybrid config? All right. Interesting. OK. We really have achieved the goal of taking all of the components that originally made up the server roles in 2007 and now became the services in the mailbox role in 2016. We really have achieved the goals of having them loosely coupled from a versioning aspect, from a functionality aspect, from a geolocation aspect. We don't care where they are, and from the user aspect as well. And I'll talk about a little bit what I mean by that when we talk about this concept that we have called every server is an island. This is something that we introduced in Exchange 2013 specifically so that we could set the stage for going forward with something like Exchange 2016. So historically, if you think about Exchange, you can break down its different elements into 3 layers or 3 stacks. You've got your protocols and your server agents up at the top. You've got your middle tier business logic in the middle. And you've got the storage with the indexing and the extensible storage engine and so forth at the bottom. Now, historically, before Exchange 2013, in Exchange 2010, we allowed, say, for instance, a component that's in the protocol layer to actually cross layer boundaries and talk directly to the storage layer on another server. This created problems. This actually defeated our original goal for Exchange 2010 of having these individual discrete server roles being loosely coupled. In fact, this required them to be tightly coupled. And so what we did in 2013, we changed the architecture such that if this server, which was version X, needed to talk to this server, which was, say, version X plus 1, a slightly later version, instead of crossing those layered boundaries and therefore running into cross-version functionality issues, now we force them to talk to their counterparts in that other server. So EWS talks to EWS, transport talks to transport, and so forth. Transport will never talk to store on another server. That type of communication is now banned in both 2013 and 2016. And so that's where we get this principle called every server is an island. And by that, all processing for any request going to any mailbox is always going to happen on that same single server. And because all processing is happening just on one server, we don't run into any versioning or functional issues. And so things are now loosely coupled as a result of that. OK, not entirely new for 2016, but new if you're coming from 2010. Now, new in 2016, as I mentioned, the client access server role has been consolidated into the mailbox role. So that is the only internal server role that you'll be deploying now. But the configuration, if you were to look at, say, for example, IIS on one of these servers, it would look exactly like what a multi-role deployment of Exchange 2013 would look like. For instance, if you looked in IIS, you'd see the same front-end website listening on 443, and you'd see the back-end website listening on 444 for the same communication. Really, the only difference is we just removed your ability to deploy the client access server role as an independent server role somewhere else, which we didn't want you to do anyway. So because we didn't want you to do it, we actually took that ability away from you, so you can't do it anymore. But everything is still there. And the functionality in terms of how we proxy communications is still very much the same way as we did in Exchange 2013, as we'll talk about in a bit. So what is the mailbox server role? It is the internal role. It's the server that hosts, processes, renders, and stores all of the data. That's mailbox data or public folder data, which also exists in user mailboxes now. It's also a server that houses the logic to route requests. So it's got the client access service components in as well. So clients will talk to the client access service component of the mailbox server, and that component will then proxy that request to whatever mailbox server hosts the active copy of the user's mailbox, okay? Just like we would proxy in 2013. Clients will not connect directly to a mailbox database. They will always go through the client access services stack. And that could be the HTTP protocol stack, or it could also be the RPC client access services stack that's buried within the store now. And of course, the mailbox server is still the building block for the DAG. I would hope that most of you know what the DAG is now. It's a collection of mailbox servers that replicate databases between each other. There are improvements in the DAG, and I'll talk about those in the high availability session tomorrow. But there are some improvements that we made to the DAG in 2016 that you'll want to be aware of. But by and large, the DAG in 2016, the fundamentals of it are largely the same as it was in 2013. 100 databases per DAG, 16 servers per DAG, et cetera, et cetera, et cetera. One big change, though, is that database failovers are now about a third faster in Exchange 2016 than they were in 2013. And for those of you keeping track, database failovers were already 50% faster in 2013 than they were in 2010. So as you can imagine, when we started in 2010, we had this concept of 30-second failovers, which was really 20 seconds is what we were seeing in Office 365 and dog food. We got that down to about 15 seconds in Exchange 2013, and now we're looking at about 10 to 12 seconds in Exchange 2016 on comparably sized hardware. All right, so what is the Office Web App Server role? This is new. This is a net new thing. Here's the history behind this. In Exchange 2010, we introduced inside of Outlook Web App the ability for you to do inline rendering and editing of Office documents. Okay? We did that using actually a third-party technology that we licensed and included inside of OA called Stellent. And we shipped that up to Office 365, and that became the first Office web viewer that we had integrated in OA up in the cloud. Concurrent with that, SharePoint was also developing their own document collaboration component that worked inside of SharePoint and also provided this inline view and edit capabilities for Office documents as well. So as Exchange Online matured, we started the process of abandoning the Stellent plugin and moving towards the SharePoint solution. So we're doing that now with on-premises as well. We've gotten rid of the Stellent and we've integrated the SharePoint Office Web App Server with Exchange. It is not a required server role. You don't have to deploy it unless you want the ability to have that inline view capability within Outlook Web App, which, by the way, is no longer called Outlook Web App. It's now called Outlook on the Web. Okay? The idea here is we're trying to brand Outlook anywhere. I know. So you're going to see Outlook everywhere. You see Outlook as the new mail client in Windows 10. You see Outlook as the client that we ship on Android and iOS devices and so forth. So now you also see Outlook on the web as the client that we ship, as the web client that we ship with Exchange. But because we know you love the OWA acronym, now we have the Office Web App Server, which can use that acronym and confuse all of your users and every administrator that we ever had. So that's what's happening here. This is only required if you want this feature. If you don't care about this feature, you don't want this feature, if you just want to give your users the ability to download these things and not work with them side by side in OA, or maybe you don't even, Outlook on the web, not OA, or maybe you don't even use that app, so you don't need this at all, in which case you wouldn't deploy that server at all. But if you do want that ability, you do have to deploy this server role. And I'm sorry to say it cannot coexist on an Exchange server, so it would be a separate server that you'll deploy, and I'll show you the options for that as well. So Exchange 2016, that was a great question. The question is it a separate license? Exchange 2016 is in pre-release, so we're not talking about licensing at all. Licensing, packaging, pricing, none of that stuff has been announced yet. So unfortunately, I don't have that information today. But if you do want this functionality, this is how you would get it now in a 2016 deployment. You would deploy at least one of these server roles in every site where you have a mailbox server, and the mailbox server would use that for rendering of Word, PowerPoint, Excel, and OneNote web app applications. All right, and so that's, if you are using it, you'll also get to familiarize yourself with WAC Discovery, WAC Discovery, which is kind of like Auto-Discover for the Office Web App Server. Now, I don't have any prize to give, but I'm just out of curiosity. Does anybody know Office Web App Server? Internally, we call it WAC, WAC, which is where a lot of this stuff comes from. Anybody know what WAC stands for? Anybody care? Seriously, not a hand went up, not a single person cares? All right, one guy cares. I'll tell you privately later then, since no one else cares. Now, it stands for Web App Centillion. Okay, there's some Exchange and Office 365 trivia for you. Okay, so this is the Auto-Discover protocol for the Office Web App Server, and that is how an Exchange server, once it has the URL for that server, knows how to find the server in the site and how to communicate and work with that server, which is important, and we'll talk about the architectural implications of that in a bit. Okay, the other major change that we've done is we've taken the REST APIs that we've already introduced in Office 365, and they've been there for a while, in fact, and we are shipping them also in Exchange 2016, Exchange Server 2016 on premises. Okay, so that's a big deal. We are moving our development paradigms forward, and not just in doing this, we are also doing things like dropping support for MAPI CDO. So if any of you are using the MAPI CDO library for connectivity to Exchange, for example, BlackBerry 5, anyone, that is no longer going to be connectable. We're actively blocking connections from the MAPI CDO library. But Exchange Web Services, it's in 2016 just like it was in 2013. Not really any changes there. Everything should work just the same way that you'd expected. So anything that you're doing today in 2013 with EWS will still function exactly the same way. But moving forward, the REST APIs are the future for development. Okay? As I said, they've been around for a while in Office 365. They're accessible not just to the online stuff, but now to on-premises. And they're really designed for more open source and more cross-platform type of work. So you can build something once and have it run on a PC, have it run on an Android phone, have it run on iOS, have it run on Windows Phone, have it run under Python or Apache, Perl, Ruby, you name it. Okay, it's totally cross-platform and built both for the web and for PC. And it's actually a lot easier to program. How many of you know how to construct a URL? I would hope everybody, otherwise you don't know how to surf the web. Right, okay, so everybody knows how to construct a URL. That's how the REST APIs work. It's just URL construction of making HTTP calls to get this information and return it and do things with it. Okay? So that is the future. You can learn more at dev.outlook.com. We've got SDKs out there for you. And like I said, it's been around for a while. And now you may already be using them. Now you can use it for Exchange on premises as well. So you write your application once, and it works on premises, works in the cloud, works in hybrid, works on any device you give your users, et cetera, et cetera. All right, let's talk a little bit more about client connectivity. We'll talk about the load balancing options, so I'm not going to get too deep into them as well. But let's talk about the fact that most of the clients now, really for some of you, all the clients that you're going to be using, but from our protocol stack perspective, most of the clients that we have are now HTTP based. Okay, so that includes obviously Outlook on the web, Exchange ActiveSync, the Exchange Admin Center, PowerShell, and of course also the Outlook client, since for those of you coming from 2010, you should also know that we've dropped support for RPC over TCP. Okay? So there's no direct TCP connectivity into the RPC client access array object anymore. In fact, that object went away in 2013, and it's still gone in 2016. You may hear us talk about a CAS array, but that's really just our way of referring to a bunch of CAS servers that are in the same load balance pool. There's no object, no RPC object that gets access, and no RPC over TCP. It's RPC over HTTP, or what we call Outlook Anywhere, or a new protocol I'll talk about in a minute called MAPI over HTTP, which is actually in 2013 as well. But those are all HTTP, so they go through IIS the same way that they would do on 2013, except they're going directly to a mailbox server now. And then that mailbox server will proxy the connection either to itself, if that happens to be where the user's mailbox is located, or to another mailbox server directly wherever it's active there. The other thing to keep in mind is that when we are proxying, it's whatever protocol the client is using. So in the case of these clients, the clients are using HTTP for the protocol, so that's what we're proxying from front end to back end, HTTP traffic. In the case of POP and IMAP, if they're using POP or IMAP, that's what we're using to proxy between front and back, the POP or IMAP protocol. Or SMTP in the case of transport. The only one where we don't proxy and that we do allow a direct connection, not to the mailbox database, but to services running on the back end inside the mailbox role, is the telephony stack. And the reason for that is the SIP plus the RTP communications, that can't be proxied. We really need the processing power and the real, the direct connection to do the real-time transcoding of the voice and whatnot. So that is something where if a is making a request, that will go in, that'll get a SIP redirection, and that redirection will send it to the services that are inside the mailbox stack. All right, not too different from 2013. Of course, the big difference is the rename of Outlook and the introduction of MAPI over HTTP. Okay, so we introduced MAPI over HTTP in Exchange 2013 SP1 and Outlook 2013 SP1, but we left it disabled by default. We gave administrators an org-wide on-off switch, so if you wanted to use it, you either turned it on for everyone or you turned it off for everyone. The big plus around making this switch is that we no longer use the Windows RPC stack as an intermediary in our communications. Okay, so it used to be we would take the RPC operations and then we would wrap them in RPCs, and then we would wrap them in HTTP to get them to the RPC proxy DLL, which would then unwrap them and figure out what they were and where they needed to go. The challenge with that is the RPC stack itself, that's not owned by Exchange. It's owned by Windows. So Windows controls what happens to that code. And the RPC stack is, in fact, out of the entire Windows ecosystem, it is the most widely used protocol in the entire Windows ecosystem. So as you might imagine, because of that, the Windows team is very leery about making any changes, because you make a change, you could destabilize the entire Windows RPC ecosystem, and you don't want to do that. They don't want to do that. We don't want to do that. So it's very difficult for Exchange to go to them and request things like, better diagnostics in the headers for the information so we could do better troubleshooting. They wouldn't make those kind of changes for us because they fear that they would destabilize their ecosystem. So instead, we decided to completely abandon using that stack altogether. Now, we still have the RPC operations, the ROPs. That's still the mappy verbs, the mappy communication that the client and server are talking with one another. So we just take those, and then we wrap them in HTTP, and we send them directly to the server for processing. So now there's just one wrapper. The way we say it is now you get to your candy faster because you've got just one wrapper. But it really is a modern protocol that eliminates the dependency on this RPC, the Windows RPC stack as an intermediary. I'll talk about the connection patterns in a minute. It is advertised via auto-discover. So the client, when it does its auto-discover request, advertises to the server that it supports MAPI over HTTP, and then the server sends down the appropriate configuration information. And then at that point, Outlook will switch from presumably using Outlook Anywhere to MAPI over HTTP after the next restart. We decided not to force the issue. So once Outlook gets the settings, it's going to change on its next restart. Why does it matter when that happens? So it could happen later that day. It could happen a week later, a month later. It doesn't matter. We decided not to put up the dialogue that said the administrators made a change that needs you to restart Outlook, blah, 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 because quite frankly, we hate that dialogue and we want it to go away. So this way, the change just gets made in the background, and when the user restarts their Outlook client, it'll automatically start using MAPI over HTTP for them. It is enabled by default in Exchange 2016, but we do give you more than just an org-wide on-off switch. I'll show you what that looks like in a minute. It does require a mailbox to be on 2013 or 2016. So if you are coming from 2010, your users won't get MAPI over HTTP until their mailbox has been migrated to a later version. And of course, you need the supported version of Outlook as well, which would be 2013 SP1 or later, preferably 2016. All right. So the options that you get, there's a couple options that you have. We still have the org-wide setting option, but now through set cast mailbox, you have the ability to control whether or not they are using MAPI over HTTP, and through the internal connectivity parameter in setcast mailbox, we now also give you the ability to control whether or not external configuration information gets sent to your internal clients via auto-discover as well. So this is a nice little safety valve where you can control and prevent your internal clients from getting the external connection information and going outside and back in for connectivity purposes. This, by the way, is a worksheet inside of PowerPoint, so you can edit that and copy and paste it right into your PowerShell scripts if you want to. All right, so these are new controls that you have, but these will only take effect in a 2016 environment. OK, so let's talk about the connection. So RPC over HTTP or Outlook Anywhere. That is a full duplex protocol. So in order for us to get connectivity without Outlook Anywhere using HTTP, which was a half duplex protocol, we needed to create two channels for Outlook Anywhere. So one was this RPC data in channel, which was the channel used when you're sending data to the server. And there was this RPC data out channel, which is what the server used to send data back. And so that meant for every single RPC session, we had to create these two channels and maintain them with persistence to keep connectivity going and to keep the conversation going with the right server so data wouldn't be lost. So MAPI over HTTP is basically a bunch of small, short-lived connections. Obviously, it's half duplex because we're not using any RPCs at all. And those short-lived connections, they go and grab the data that the user's trying to get at. And then at the end, there's this one long-lived connection, and that stays open and gets maintained in a persistent state. And that is there so that the server can tell the Outlook client when there's work for it to go get done. And then the short-lived connections come in, and they'll go and get the data and show that. So that's one big difference there. Another big difference is that you can't see it on this slide, but we have this new component called the MAPI HTTP handler. When you're using MAPI over HTTP, it's within this component where we'll load the RPC client access service. So that'll be different for clients using Outlook Anywhere. Well, they'll get that loaded and speak to the RPC client access service that's running sort of in the CAS area of the mailbox role, versus this is actually inside the MAPI handler inside IIS. So there's two different places now that we have the RPC client access stub, one for Outlook Anywhere, one for MAPI over HTTP. All right. All right, let's talk a little about coexistence. And then we'll talk a little bit more about this in the deployment session that's after this one as well. But I wanted to bring this up so that you could see what we're talking about when you introduce 2016 into a 2010 environment or when you introduce it into a 2013 environment. OK, so remind me, who's got 2010? All right, so this is what coexistence would look like for you. Up there, we've got HTTP client, could be any of the 5 clients that we talked about. We've got our load balancer, and that's sitting on top of your mailbox server running 2016. And then over here, you've got the 2010 infrastructure, where even though we wanted you to do multi-role in 2010, for illustration purposes, I'm showing CAS and mailbox separately for 2010. But ideally, this would be still one server in 2010. So we had this legacy proxy request. The user's mailbox is located on Exchange 2010. And again, simple rule, we're always going to proxy the request. Whatever CAS gets it, we're always going to proxy the request to whatever mailbox server hosts the active copy of the user's database. So that's where it is. It's on this 2010 server. So the request will go through the load balancer, go through IIS, and that will get proxied to the CAS components or CAS server if it's a single server role. And those CAS components will then talk directly to the mailbox database. If the CAS components are on that same server, that's going to be a local RPC communication, so it's going to be very fast. Now, if we're in another site, same thing. Okay, it doesn't matter, we're just going across another site. In this case, it's a non-internet facing site. There's no external URL, there's no load balancer, so we're doing a cross-site proxy request, not a cross-site redirect. And again, the same thing. 2016 is simply going to find where that mailbox database is located, found it over here, and it's going to proxy that request over to that server. Okay? Now, a cross-site Outlook on the web redirect. So now we've got another site, but it does have a load balancer there because it does have an external URL, or rather, it does have its own namespace that we can redirect to. So the client makes the request. They find out that there's an external URL, so it gets redirected over to 2010, and the 2010 CAS answered, and then talks RPC to the mailbox server. If this looks familiar to you, it's because it's exactly what 2010 did when you introduced 2013 into the environment. Okay, so it's going to be largely the same experience when you introduce 2016 into a 2010 environment. It's going to have that same behavior all the way around. All right, let's talk about coexistence with 2013. How many of you have 2013 in the mix? All right, so here's what it's like if you introduce 2016. Now, you actually have one of two choices, because 2013 can up proxy to 2016 just like 2016 can down proxy to 2013. So it doesn't matter which front end answers, 2013 or 2016, that request is still going to go to the mailbox server that hosts the active copy of the database. So when we talk about phase 1, this is where you're introducing Exchange 2016 into the 2013 environment, but you haven't moved the namespace over. You're going to let 2013 proxy up to 2016. So you're really not messing with the 2013 environment at all. You're just introducing 2016, which 2013 will discover, and start up proxying to it. So it'll look like this. We'll see that the mailbox is still, or the mailbox has been moved to 2016, but the request is still going through the load balancer, which is going through 2013. 2013 is going to proxy that right to the protocol stack on that mailbox server. Okay? And that's why we call this phase 1, is when you haven't changed the front door. You're still having everything go through 2013, even though you've introduced 2016. And this is new. You couldn't do this in previous versions of Exchange, but you can in 2016. Similarly, if we have 2016 in another site, again, the request will come in. We'll see that it's on a 2016 server, and the 2013 CAS will simply proxy that request over to the mailbox stack on that 2016 server, just like it would another 2013 server. Now, let's say there is an external-facing site. It'll be a redirect, just like you might expect, because we've got another name to send it to. So we redirect there, and now we're talking just to that mailbox server, and the mailbox server is proxying to its local database in that case. Okay? Pretty simple and straightforward stuff. We tried to make things as easy as possible. Here's phase 2. Phase 2 is when you've swapped the front door. So now you still have 2013 and 2016 in the mix, but now 2016 is answering the client requests. And it's got the front door, and it is, in fact, doing the proxy requests from 2016 over, in this case, to the mailbox that's on 2013. This is the legacy proxy request. It's very similar for the cross-site legacy proxy request. Or if you had a redirect request, it would look very similar to this. What's really interesting is going back one, if you had actually deployed separate server roles in this other site, such that CAS was literally a separate server from Mailbox, you could actually go ahead and begin the process of decommissioning your CAS servers. Because at that point, your 2016 Mailbox servers are handling your client access server traffic, and they'll proxy right to the Mailbox server role. They don't need another CAS in that site in order to do that thing. So you could begin the decommission process if you deployed separate roles, which, again, we hope you didn't. OK. All right, so let's talk about how Outlook on the web, again, formerly Outlook Web App, works with the Office Web App Server. So what we have here is we've got Outlook on the web, Exchange 2016, and the Office Web App Server. So I mentioned WAC Discovery. There's a WAC Discovery URL that you'll configure for Exchange. And then once configured, Exchange will use that URL to send the WAC Discovery request over to the Outlook Web App, or Outlook Web App Server. Actually, that shouldn't say Outlook Web App Server. That should say Office Web App Servers up at the title. I'm just going to fix that real quick. So look, it was perfect all along. Look, it said it the whole time. Office Web App Server. OK. Exchange will get back a table. And the table will be the list of files that the server supports viewing and editing, so that Exchange can compare it with the file type that the user is asking for. Now, keep in mind, both of these servers are communicating. They're not on the same server because the bits can't coexist on the same server, but they do need to be in the same site, and preferably on a LAN, because they're going to be communicating a lot of information back and forth, including all the attachments. So if there's an attachment to be rendered, it might be 20 megs, 25, 35 megs. That's got to be sent from Exchange to the Office Web App Server, and the Office Web App Server has to transcode it and render it and send it back to the Office Web App client that's running inside of Outlook on the web. And so that's why we need very good connectivity between these servers for them to do these things. So we get a table back. The user opens a mail that matches one of the file types that's in the table. So they will then see these supported actions, typically view or download. If they choose view, then Exchange is going to build a URL. and populate it with an OAuth token, and that token will be sent to the Office web app server for authentication and figuring out what files the user has access to and can edit. And then the user clicks the attachment that loads that iframe that you saw in the side-by-side picture and begins the rendering process of displaying that file within that iframe inside what we would call the OWAS client, like Word web app or Excel web app and so forth, or PowerPoint web app and so forth. Okay, so this is the communication path that will happen. Largely, steps 3 to 7 will happen every time a user opens a file this way through Outlook on the web. And again, this is optional connectivity. It's not required, but if you do want this functionality for your users, you will have to deploy one of these servers. All right. Let's talk about namespace planning. All right, so the good news is we don't need the same amount of namespaces that we needed back in 2010. In fact, that largely changed for us primarily in Exchange 2013, but the same thing still holds true in Exchange 2016. When we talk about namespaces, there's 2 different models that you can deploy. One is a bound model, the other is an unbound model. I'll show you what both of those mean in a bit. But figuring out your namespace is important because the namespaces that you choose and the design that you choose will directly impact your choices of certificates and the names on your certificates and so forth. And so typically with certificates, the more names that you put on them, the more expensive that they are. So we want you to minimize the number of host names that you're using so that you can minimize your certificate costs as well. So if you're coming from 2010 to 2016, the good news is you're going to see a reduction in namespaces, and you won't have to introduce any legacy namespaces. If you're coming from 2013 to 2016, they can in fact share a namespace, so you might not need to make any namespace or certificate changes. You can do things like use regional namespaces if you want to control traffic. I'll show you some examples of that in our preferred architecture. And you can also do things like have specific namespaces for protocols if you want per protocol availability, and I'll show you what that means as well. Ideally, though, whatever model that you use, we want you to use a configuration known as split DNS, and that is where you're using the same names internally and externally. It's just that in internal and external DNS, they point to different things. Internally, obviously, it's going to point to the load balancers that are sitting in front of your pool of Exchange servers, and externally, it'll point to your firewall or your load balancer if you're using that for a firewall, whatever your external access point is. And this way, you don't have to have, again, extra names. You use the same names in both places, and your users don't have to know one name for where they are and a different name because they're somewhere else. All right, so let's talk about the bound model first. So the bound model means that the namespace is tied to a particular data center, like east or west or north or south or whatever you want to do it. In my example, I'm using east and west. So I've got 2 different users. I've got, say, for example, I've got Sue. She's somewhere in North America. Her database is located in DAG 1, and it's currently active in the west data center. So she'll be using west.contoso.com. And we also have Jane, somewhere in North America, whose database is active in East, and so she'll be using east.contoso.com. Okay, so that's the bound model. Wherever the user goes, they're going to use that URL that you've given them, and that's going to take them to a specific data center for traffic control purposes. The unbound model, and in fact, in this case, the unbound model that happens to use a single namespace, just mail.contoso.com, is one where that namespace resolves to multiple IPs, VIP1 and VIP2, and then round robin is used. So when Sue accesses that URL, it's going to be a round robin. She'll get one of those data centers first. And whichever one she goes through, whether it's VIP1 or VIP2, it's going to proxy, again, to wherever her mailbox is located. So as Sue moves around, she just continues to use the same URL. Maybe she'll hit VIP1, maybe she'll hit VIP2. It'll be about 50-50, and in this scenario, you'll see about half the traffic hitting each data center, and therefore half the traffic proxying over the WAN to each data center. But this is by far the simplest and easiest type of configuration. and is in fact what we use in Office 365 and Exchange Online around the world. So we know it works very, very well for those purposes. All right. So load balancing. We'll talk a little bit more about load balancing. So when we released Exchange 2013, we kind of made this big deal about how you didn't need a layer 7 load balancer anymore because we didn't need application session affinity at the load balancer layer anymore. And that kind of, opened the door for everybody to start using layer 4 load balancers. We probably should have been crisper in our guidance because you still have opportunities to use both types of load balancers. And I'll talk about that in a bit. But basically, we no longer need session affinity at the application layer. So it doesn't need to be maintained at the load balancer layer. That was really largely the big change. That didn't necessarily mean that you would stop using your layer 7 load balancer. What it really meant is that maybe you continued to use it, but you used it without session affinity, and you used it in a different way that I'll show you in a minute. The other thing that you want to keep in mind is both 2013 and 2016 have managed availability built in, and they'll do their own health checks of the virtual directories, just like the load balancer will check virtual directories if you configure it to do so. And you want to make sure that your load balancer is configured to specifically ping the healthcheck.htm files that managed availability has set up. And so that way, the load balancer results will match the same results as managed availability. They should both be able to ping that or not if it's not working. It shouldn't be one or the other. So you want to make sure that that's kept in sync. And your load balancing configuration, along with your namespace design, will actually directly affect how you will configure things for health checks and for managed availability and for the probes. So the recommended approach, and I'll talk about this in a bit, is really just to use the single namespace like you saw before and continue using layer 7 but without session affinity. And again, I'll explain why in a little bit. But before I do that, I want to talk first about connection management. How do we get all of the connections to the load balancer and then from the load balancer over to all the servers that you have in your load balance pool? So we've got two recommendations for that. One would be using round robin. The other would be using leased connections. So both of them have their advantages and both of them have their drawbacks. So when you think about something like round robin, that has a very slow convergence time for long-lived connections. That would be one of the drawbacks there. And when you think about something like Outlook Anywhere, RPC over HTTP, those are all long-lived connections. So it will take a while, if you're using Outlook Anywhere and round robin, it would take a while to get that sort of uniform dispersal of connections across your server pool. Versus leased connections, that has a very fast convergence time because it's always sending requests to whichever server has the least amount of connections. But a drawback there could be, well, that certainly describes a brand new server that you're introducing into the load balance pool that has 0 connections. So it will always have the least. So it could get inundated with requests as a result of using leased connections. So for that reason, if you're using leased connections, you want to make sure that your load balancer also has a feature. They go by different names. Sometimes they're called slow start. Sometimes they're called ramp up, things like that, or warm up, something like that. Look for that kind of feature. If you have that kind of feature, then use leased connections because that will mitigate the instability that can result from a new server being inundated with requests. If your load balancer does not have that feature, then don't use leased connections, use round robin instead. Okay, so that would be our guidance there. All right, so let's talk about the choices. So again, in 2013, we made this big deal about how we don't need the layer 7 load balancer anymore, and everybody could now go down the path of using layer 4 and having just the load balancing being done at the transport layer. So what does that mean if we're load balancing at the transport layer? I've got an IP address, I've got a namespace, and I've got a port. Okay, I've got a name, mail.contoso.com, points to a certain IP, and it's HTTPS, so it's going through port 443. That's all I know. I don't know anything else. I don't know what virtual directory it's going for. I don't know the full URL. All I know is that bit of information. But it doesn't really matter. It's all the same. Now, if you're using this configuration, the one that you see up here, you need to choose how the load balancer is going to do its health check because, again, it doesn't have this concept of multiple virtual directories. It just knows the IP address and the port. So what you end up having to do is, out of all these different virtual directories, which also map to all the different protocols that we have, out of all these protocols or virtual directories, you need to pick one. That's going to be the most used protocol, and that will be the one that you'll end up having your load balancer do the health check against. Okay? Because that's the flexibility that you get in this. You get the benefit of an inexpensive, easy to configure load balancer and a single namespace, but basically you get per server availability, not per protocol availability. Okay? And what I mean by that is when we do mail.contoso.com and we're only checking for OA, if OA happens to be up but all the other protocols are down, except maybe for auto-discover because it has its own namespace, then you're going to run into a problem where those other protocols are going to fail even though OA is working. And conversely, the same thing is true if OA is the only protocol that fails and everything else is working. Now you're taking the entire server out of rotation because one protocol failed, again, which you don't generally want to do. But as long as the health check passes, as long as the OA virtual directory is healthy in this case, the load balancer will continue to send traffic to this particular server. So that's one example. Another example would be to use still a single namespace, but using layer 7 without affinity. So same thing. You're doing a health check, except now, because you're layer 7, it can understand things. Now, in this case, the reason it can understand the virtual directories that we're trying to get to is in this configuration, not only are you not using session affinity, but you're also terminating SSL at the load balancer so that the load balancer can unpackage and figure out where it's going to and direct the request appropriately. So here we've got a single namespace, layer 7 without affinity, SSL being terminated at the load balancer. All right, now this would be the approach that would be recommended by us because it is also, in fact, the same approach that is recommended by pretty much every load balancer vendor that works with Exchange. So we are in complete agreement with them, and that's why this is our recommendation here. There is one other option that you have, and that would be using multiple namespaces with layer 4. And this would give you per protocol availability, but as you can see here, you'd have to have a distinct name and a distinct VIP for every single virtual directory. It's easy to configure, but it's actually operationally complex to manage. And for that reason, it's not something that we would really recommend. But it is a viable alternative if you want to use layer 4 but still get per protocol availability. So keep that in mind. So another way to look at this is the trade-off between functionality and simplicity, where you've got the single namespace layer 4 over there, and then the single namespace layer 7 without affinity over here. This would be the hardest to configure, but it would provide the most functionality. That would be the easiest to configure, but it would provide the least functionality. Again, typically we would hope that you would go for per protocol availability over per server availability, but that is an option for you if you want that, especially if you're in a smaller shop where you just have a few servers that you need to keep tabs of. Okay. Now, for namespace planning and load balancing of the Office web app server, that will always be the same. It's very, very easy because it's a static configuration. So even if you're using the unbound namespace model for Exchange, you're going to use the bound namespace model for the Office web app server. Put slightly different, we require an Office web app server in every Active Directory site where you deploy a mailbox server. Okay? And because that server will always be there and the one that's used, that actually effectively eliminates any site recovery or disaster recovery steps if you have a site failure and you need to activate another data center. Okay? You don't have any steps to do there because that other data center will already have its own Office web app server that the local servers will be using. We do also require persistence at the load balancer level for the Office web app server, and that is so that we can preserve the data and fidelity of the experience and not switch servers in the middle of someone's edit session and potentially lose data and so forth. So there will be some persistence that you have to maintain there. So again, it doesn't matter what front end the user goes through, it all is determined by where their mailbox database is. So in this case, if the mailbox database is in the west side, that's where where Exchange is going to go to look for it. Again, it will do that by the discovery URLs. If the mailbox, even if they go through the front end on the east side, we're still going to proxy to the mailbox server that hosts their mailbox, and we're still going to talk to the Office web app server that is in that site. Okay, so the last section is going to be drilling down into the actual preferred architecture, or as we call it, the only architecture we want you to deploy. So whatever you do, do not deviate from what I'm about to tell you, or Exchange will not work in your environment. No, I'm kidding. It'll work, but seriously, don't deviate. I don't want to scare you. It'll work. Well, it might not, depending on what you do. Okay, so let's start with the namespace design. I think we've talked about that well enough. Ideally, we would want you to have a single namespace. Preferred architecture is just one worldwide name that every user has. It's the same name that they use internally and externally, managed through split DNS, potentially managed through GeoDNS solutions that can direct a client to a closer VIP if you want to control traffic that way. But either way, it's a single namespace per site resilient data center pair. So for every 2 data centers, a single namespace for them for each protocol. So one for HTTP, one for SMTP, one for IMAP if you're using it, and then, of course, your auto-discover namespace. For the, it says Outlook web app server again. I don't know why that keeps, somebody wants to call it the other name. Let's just fix that. All right, so for the Office web app server, a single namespace space per data center. So you can see we've got one in Auckland and one in Wellington in our data center pair scenario here. Okay, the load balancer design depends on which virtual IPs we're talking about. For the Exchange virtual IPs, no session affinity. Again, one virtual IP per data center and per protocol health checking. So you're using that layer 7 load balancer without affinity, or you could be using multiple namespaces in layer 4. You do need session affinity for the Office web app server, so don't forget that. You just don't need it for Exchange, but you do need it for that. And again, round robin, geographic DNS, or some other mechanism should be used to control traffic as well. There is subnet mask ordering in Windows DNS that you can use to get a form of GeoDNS, which will look at the subnet that your client is calling from and try to direct to a server IP that is closest to that subnet as possible. So there are opportunities in Windows to get sort of a poor man's GeoDNS if you didn't want to get a third-party solution on top of it. For the DAG design, we want you to use an unbound DAG. In other words, have it extending across multiple data centers. And we want it to be symmetrical. In other words, we want it to have an even number of members and the same number of members in each data center. No more odd number DAGs. Okay? Everything should be even, even, even. Makes it super simple. Every data center should be its own Active Directory site. Okay? If you don't do that, how many of you are stretching Active Directory across multiple locations? Okay, don't do that for Exchange. If you do that for Exchange, you don't get transport site resilience. Okay, that's very important because we use things like safety net and shadow redundancy to make copies of every single message, both in transit and after they've been delivered. And if we see a DAG stretched to another site, we intentionally make those copies in the other site so that if your primary site blows up, you can recover all the data, even if the messages have already been delivered. Okay, we can only do that if you have a AD site topology that lets us see different sites. Okay? If the servers are in the same site, then we could be dropping a message right to another server in the same rack, and if that rack blows up, it takes out all the copies. You don't want that to happen. We also want you to increase membership in your DAG until you get to 16, the maximum amount, before creating additional DAGs. So in other words, instead of 2 4-member DAGs, make 1 8-member DAG. And we don't want you to deploy a cluster administrative access point anymore. In fact, I'll talk a little bit more about that in the HA session tomorrow. But basically, the default in Exchange 2016 is to deploy a DAG without one of those. We want you to use a single network in your servers, and that single network card at least gigabit Ethernet, preferably 10 gigabit Ethernet. That single network will handle both client and replication traffic. We want the active copies distributed equally across all servers in the DAG according to activation preference, so your DAG is balanced. Both the scripts that we include in Exchange and the Exchange server role calculator will be able to do that distribution for you, so the guesswork is taken out of that. And we want you to use Exchange native data protection. Okay, so that means using things like a minimum number of copies and a lag copy, and not taking traditional backups and so forth. We also want you to deploy your witness server because you're using a symmetrical DAG with an even number of servers. You'll have a witness server. We want that witness server to be deployed in a third data center if possible. If you don't have a third location, we now support deploying it in an Azure IaaS infrastructure as well. So you could hook up both your data centers to Azure and get automatic site failover using an Azure-based witness. We want 4 copies of each database, 2 in each data center. And one of those copies, as I said, will be a lag copy with a 7-day lag with our automatic lag playdown feature enabled. And I'll talk about that in the HA session as well. We want the servers deployed on commodity hardware, dual socket only, usually 20 to 24 cores total, and up to 196 gigs of memory. Note the asterisk there. That could change. We're still looking at what the upper limit for memory is, and we'll have on TechNet details of that when we ship Exchange 2016. And we want all servers to handle both client connections and mailbox data. And of course, that was our wish list in 2013. In 2016, we forced you to do that because we took away the other server role as a separate thing. For the storage design, we want all of your servers to use JBOD storage. RAID is supported, but the preferred architecture says you're using JBOD, preferably the large capacity SAS disks, but SATA disks are also supported. We usually prefer SAS because they've got a longer enterprise duty cycle, so they do tend to last a little bit longer than SATA drives, and they will work a little bit more performant than SATA drives. Battery back cache controller is necessary, or maybe flash-based if you're got a futuristic server. Multiple databases per volume, ideally matching the number of database copies. So if you're using 4 database copies, we want you to deploy 4 databases per volume as well. And then we want you to configure auto reseed with a hot spare so that if one of your disks does die, the system can automatically format that hot spare and reseed the database copies that were affected by the dead disk. Data volumes should be formatted with the resilient file system, although for the log and database volumes, you have to disable the data integrity features. But we still prefer having them formatted with RFS and then protected with encryption from BitLocker as well. Doesn't mean that you need a PIN code or anything, but you should at least run the encryption and have your drives encrypted, so if something is stolen, you're protected that way as well. We want you to use GPT partitions, and then depending on if you're using RAID or where the binaries are, your formatting will either be a 64K allocation unit size for the binaries, or 256K or larger multiples thereof if you are using RAID. Again, though, RAID would be overkill for Exchange. Just a JBOD configuration is really what we would prefer. And then the storage controller cache, it depends on if you're using direct attached storage or storage area network. That will depend on how you configure your write-back cache. Typically for a SAN, we do give you this minimum guidance of 75-25, but we will defer to the storage vendor. So check with your storage vendor to see what they want the write-back cache set to. And then obviously when you're running JetStress to validate your storage, if you are using BitLocker or if you've got some sort of virus scanning, you also want to make sure that JetStress is configured with those enabled as well. All right. And then some miscellaneous things. Not 100% part of the preferred architecture, but they will be because there's stuff we either do or do not want you to do. For example, we don't want you to restrict any traffic between Exchange and directory servers, or Exchange and link servers, or Skype servers, or any other servers. So I know some companies have firewalls around their data centers. Okay? You actually have to open all the ports in order for Exchange to do that, or you're not in a supported configuration. We also can't have you restricting the dynamic TCP port range, and we can't have you disabling IPv6 on the servers as well. So don't do that. Don't disable any services post-install. In Exchange 2013, a lot of customers were a little bit put off by all the work that managed availability was doing, so they decided to just turn off the health service and not let it do anything anymore. Don't do that. That's not supported. Okay? Managed availability has to be able to do its thing, so don't turn off any services at all. Use the high performance power plan in Windows. Believe it or not, Windows Server does not default to the high performance plan. It still defaults to the balance plan. You don't want the balance plan because the balance plan starts doing all sorts of power management thingies that you don't want on your Exchange server. So make sure it's using the high performance plan. And in a physical deployment, turn off hyperthreading. It's okay for virtual deployments, but in a physical deployment, turn it off. It's not something that we want you to have on the box as well. And then lastly, believe it or not, we have to say this because there's a lot of customers who just don't do this. You've got to keep your servers and your clients up to date. Okay, a lot of admins are fantastic about keeping the servers up to date, almost religious, if you will. The day the update's released, it's on their server and in production, and they're protected. But then they forget about the clients, and the client doesn't have all these other necessary updates, and then that causes problems on the servers, and the admins don't know why, and it's because of these out-of-date clients. So I may be preaching to the choir a little bit here, but keeping your clients up to date is just as important as keeping your servers up to date. Okay, so to wrap it up, this is what the preferred architecture would look like if you had regional namespaces, and even within the regional namespaces like Wellington and Auckland, we would still be using round-robin load balancing between the two of them. So you still have the ability to do the regional namespaces and get some load balancing. But again, our preferred configuration is really just the one single namespace, and then have the load balancing occur across all data centers and let Exchange just send the traffic where it needs to go. Now, we've talked a lot about the server side. There's just one more thing I want to say about the client side, and that is deploy large mailboxes. Okay? Don't deal with stubbing. Don't deal with third-party archives. Don't deal with PST. Deploy large mailboxes. What do I mean by large? 100 gigabytes or more. Okay, maybe that's too much for you. 25, 50, maybe 100 or more, but deploy large mailboxes. The benefits are substantially increased productivity for your information workers, because they might get now 1 to 2 to maybe even 4 years worth of mail. I've kept almost every message I've gotten at Microsoft since I joined more than 11 years ago. And I actually get thousands of messages every day because of the internal stuff I get. And my mailbox right now is only 25 gigs. And that's after 11 years of keeping everything at Microsoft. So you can see that after 4 years, an 11 gig mailbox is going to be small. So deploy large mailboxes. And if you're worried about the client side, both Outlook 2013 and 2016 give you the slider bar that you can use to control the size of the OST file on disk. So if you've got an old laptop or a tablet with a small amount of disk space, you can use the slider and maybe only keep 6 months or 3 months mail locally. And then when you go to search or do other things, it automatically integrates with the server and goes online, so everything is all nice and seamless. But it does allow you to have a large mailbox without blowing up the OST file on the desktop as well. All right, well, there goes the bird. Okay, so with that, so now that you've seen the preferred architecture for 2016, again, a lot of this also applies to 2013 as well. Hopefully you will adhere to this because, again, this is something that we've given a lot of thought to, and it's something that we think, especially based on the fact that we use this architecture in Office 365, the fact that it works for us should work very well for you as well. All right. That's it for me. There's another session starting here in about 15 minutes. We'll talk about deploying 2016. And then tomorrow, there's a high availability and site resilience session as well. I will be at the Hub happy hours. But like I said, if you have any questions that you can't remember at the show, it's schnall@microsoft.com. All right. Thank you.